domain for that. So we're going to limit our domain to only the part of the differential equation that has the particular solution. And I'll show you that, what I mean by that. So solve the differential equation dy over dx equals y over x. So step 1, what do I do? Okay, so I have, however you get there, 1 over y dy equals 1 over x dx. However your brain gets you there. So step 1, separate the variables. Because if you weren't here yesterday, that's okay. So get the y's on one side, the x's on the other side. You are using multiplication to make that happen. Okay, good so far? Anti-differentiate, integrate both sides. Plug in the initial condition that finds C. Okay. Did anyone not watch the video? Okay, how's it going? Okay, so far? Let me know if I need to explain. Okay, so I'm going to now use the initial condition. I said that f of 1 is E. So I'm going to use that. 1 is the x value, y is the E value, so I'm going to plug those in. What is natural log of 1? What is natural log of E? So natural log of E is 1, natural log of 1 is 0. So the C value is 1. So I can rewrite this as natural log the absolute value of y equals natural log the absolute value of x plus 1. Any questions so far? I want to get y by itself. How do I do that? E. So I have the absolute value of y equals E to the natural log of the absolute value of x times E to the first power. That was in there. How in the world did I do that? Okay, it's property of exponents. When you're adding an exponent, you can split that into two pieces and multiply. So E to the first power is now a constant. What happens to E in natural log? We cancel out. So I get the absolute value of y equals E times the absolute value of x. Any questions about that? For my particular solution, I go through the point 1e. So these are both exponents. And so the property of exponents, you can split that up if you were going to think about it backwards. If you were going to go from here up to here, you just add your exponents. So we split that up. Absolute value of y means that E times absolute value of x could be a positive value or it could be a negative value, right? I want to choose which one it is, whether it's the positive value or the negative value. Which one is it? Positive value, right? So this is y equals E to the absolute value of x. And because of the limit we're going to put on the domain, probably even just E times x would work, because we're probably only going to get a line right. So, what's the domain? Well, where am I going to have to go? 2 places to look for domain. The original equation and the solution. Solution has no problems, does it? If you just looked at the solution, you would say the domain is negative infinity to infinity, right? Why is 0 an exception? The original equation had x in the denominator. That's a problem, right? So again, you have to look at 2 pieces to get domain. So the domain is negative infinity to 0, 0 to infinity. Agreed? Write that down. over union 0 to infinity. That is the entire domain. But I told you that we're only going to pick one piece. We're never going to have a break in our domain. So which one of those two pieces are we going to choose? The second part. Why? Because I don't know anything about the first. I know when x is 1, I know a y value. So I know something about that piece. So our domain, though originally it was negative infinity to 0, 0 to infinity, we are only going to choose the right-hand piece of that. Because that's the only thing we know enough about to pick a solution. Technically, the domain of a particular solution of a differential equation must be an open interval that contains the initial condition on which the differential equation is true. Practically, this means that the graph must go through the initial point, but may not cross an asymptote or an undefined point. We'll get a little bit more into why on today we cover what's called slope fields. We'll kind of see pictures of why you wouldn't want to make those assumptions about that left-hand piece of the domain. So the only part of the domain is yours. Let's do it. So it's a little tricky. You got to think about two things and then only pick the part that goes through your initial condition. Yes. Or you could just say it's your truth. Another differential equation. Solve in safe domain. Now this is good news for you on your homework. You probably had several that you could do the differential equation, you just couldn't state the domain yet. All you've got to do is go back and look for domain on those problems. What's the first thing you're doing? Separate the variables, right? Get the y's on the left, the x's on the right. So I get the square root of y dy equals 2 dx. Good so far? Anti-differentiate or integrate both sides? That's y to the 1/2 power. So I'll add 1 get y to the 3 halves times 2/3. I go, oh, okay, where I got that? Y to the 1/2 equals 2x plus 6. I have an initial condition, 0, 9. Those of you who weren't here yesterday, if you don't have an initial condition, you would leave this C in as a C and just solve the last. All the ones today. We couldn't find it. So we're going to put 0 in for x, 9 in for y. Uh-oh, we got to know what exponents mean again. Yes, exponents. What is a 3 halves power?
That would be 27.
Yes, it has to be like that. Square root it first because it's easier than cube it. So square root of 9 is 3 cubed is 27. 27 times 2/3 is 18. And so my equation is 2/3 y to the 3 halves equals 2x plus 18. Now we will get y by itself. I would multiply both sides by 3 halves. You could divide by 2/3 if you would rather. So multiply by 3 over 2, I just get 3x. Multiply by 3 over 2, I get 27. Is that right? do the, what, no. How do I get y by itself?
You take everything to the 2/3 power.
Very good. Everyone agree? 2/3 power. Like stairs. Yes. We want to get y by itself, so we have a 3/2 power raising to the 2/3 power would undo that 3/2 power. I do want to stop and think about what did I just do? Because at this point I could need a plus or minus. Maybe. Depends on what power I just raised it to. Didn't I really just cube root and square? Cube rooting, I don't need a plus or minus, right? But I need to think about that because if this had been a 3/2 power, I would need to do a plus or minus because I would have square rooted. So if you raise both sides to an even denominator, don't forget your plus or minus because it's a square root if you do that. Or if you would rather actually think about it as a square root if you need to. But this one's a cube root, so you can leave it like that or you can write it as a cube root squared. It's up to you. No plus or minus, which means I don't have to choose which one. It says defined everywhere. Yeah, cube root is defined. That's another good reason to know what I just did, because square root, we know it would have to stay positive, right? But cube root can be anything. Square, I can do. That's good. No, it can't happen. Y can't be negative, and y can't be 0. I agree. But I asked domain, and you told me y's. So what's that mean? We need to know what values would make y negative or 0, correct? This is y, right? So I need y to be greater than 0, strictly greater than 0. So I need to solve that really quick. I have a lot of options, but I want to know. So for domain, I'm going to solve when it's y greater than y is. When is that y value? This thing. So 3x plus 27 to the 2/3 power greater than 0. Very good. That's one of the quick ways to think about it. When does it equal 0? Everyone agree negative 3 would make it equal 0. How did he get that? Besides just what steps would you go through to make that happen? Look at when the inside equals 0, subtract 27, divide by 3. Everyone agree? Actually, yeah, subtract 27, divide by 3. 9? Negative 9, not negative 6.
Why can't y equal 0?
That makes sense. And it can't be negative either, because of the square root. It can't be 0 because of the denominator, it can't be negative because of the square root. So does everyone agree negative 9 is my place where I'm either greater than or less than on either side of negative 9? You can do a sign chart, or you can think about it in your head, it's up to you. Sign chart, you put negative 9 on the sign chart. Remember, less than negative 9. Negative 10 would give me a I think it should be a positive. I didn't get anything from that positive except at negative 9. What do you think? Why? Why did I put that? It's squared, isn't it? It's actually plus and plus. So the domain is negative infinity, negative 9 to infinity, right? Negative infinity and negative 9 to infinity. Now, why did I just say it's negative 9 to infinity only? Go look at our initial condition. What was the x we used? 0. Which interval? about those on Friday or Thursday maybe. This is a slope field, but I did want to pull one up to kind of show you why we can only use this piece as our solution to our differential equation. The derivative that we had at the beginning tells us a bunch of slopes, right? So this is actually a graph, a field plot of every slope that they flew in hand drew. This is all the different little slopes from that derivative, right? Well, at -9, the slope is undefined, correct? If this is a solution, I don't know where this would pick back up over here. With that asymptote at -9, everyone know what I mean by that? Maybe it picks back up down here, maybe it picks up here. I don't know because my point didn't go through that. Does that make sense? So we can only use the slopes that go through our point 0, 9. That's the only one that we can use to get a particular solution. Here's what kind of this is like. Envision this slope field being like a weather jet stream. At the wind, you'll know, have you all seen the pictures, little arrows on the maps? So, and you drop, say, pretend we could make that flat, and we drop a leaf somewhere in there. Well, where would it blow, right? Well, it depends on where you drop it, right? It depends on your initial conditions. And I can't assume things about what would happen back here based on where I dropped it here. And that's why differential equation has something to do with it. That makes sense. Talk a little bit. I know it's something I was confused about when I was in high school. So. Do what? Wait a minute. Let's see. Another example. This one is not a domain question, but we can talk about it when we get there. We ask. Don't answer that. How do we fill out domain? Take two things into account, the original and the solution, and then only pick one interval, the one that goes through your x that you were given, if there's multiple intervals. If your interval is -infinity to infinity, then it's -infinity to infinity. But if there were two separate, I don't think it's that cool. 72. Okay, so let's first work this differential equation. Okay, what's the first thing I need to do? Separate the x's and y's. I know I'm going a little fast on this, but is this where y'all got? I think that is a question on your gateway. That left-hand piece. What are you going to have to do that integral? You're going to need to use substitution. If you haven't mastered that yet, you need to. It's going to hurt you on this test if you don't get it mastered before the test. It is due tomorrow Sunday. Making you master it. So, you need to work on that. Okay? Good so far? We want to integrate both sides. I do need to use substitution on the left. So, I'm going to let u equal natural log of y. Works out nice because what's du? 1 over y dy. Why is that nice? There's another 1 over y in the problem, so when I multiply that over, those y's are going to cancel. So I get the integral of u over y times y du. The y's cancel. I can int differentiate u, which is 1/2 u squared. And then I need to replace that u with natural log of y. So 1/2 natural log of y squared equals negative 1/2 x squared. So far so good. So we did need a u substitution on that. X is 0, y is e squared. So I get 1/2 natural log of e squared equals negative 1/2 times 0 squared plus c. What is natural log of e? Yes, sure. 2, good. Why is 2? Okay, so if you bring the power in front or the natural log, you can, however you want to think about it. So you get 2, 2 squared is 4, 4 divided by 2 is 2. So, am I going too fast? So I get 1/2 natural log y squared, negative 1/2 x squared plus 2. Solve for y. Takes me a little bit. First, I need to multiply everything by 2. So far, so good. Square root both sides. What do you do when you square root? I'm going to go ahead and stop right there and decide which one, whether I need the plus or the minus. How am I going to make that decision? Plug in 0 and e squared and see which way the equation makes sense. Everyone know what I mean by that? So if I plug in 0 in the right, I get 4, the square root of 4 is 2. Right? Natural log of e squared, I get 2. Do they both need to be positive? Yes, so I'm going to choose the plus. Everyone see how I'm making that choice? Remember, we're always going to make a choice on which one it is, and I would just go ahead and do that as soon as I see, oh, there's a plus or minus. Decide which one it is. It is the plus, e to both sides, so I get y equals e to the square root of x squared, it's negative x squared, sorry, plus 4. Okay, so that is my solution. I'm done. What's the domain? On the AP exam, they will not ask domain, but they want it. So you need to answer domain on an open response AP question every time. Always limit the domain accordingly. So first I'm going to think about this. Is there a domain issue here?
Like where? Yes.
Square roots can't be negative underneath, so I know negative x squared plus 4 needs to be greater than 0. I'll think about that in a second. Also, y can't be 0 or negative. Can't put a negative in a logarithm, can't put a 0 in a logarithm. I think that's okay, because this is never 0 or negative anyway, right? E to the power is never 0 or negative, so it kind of saved me there. Does that make sense? Because this doesn't allow for a 0 or a negative if it's not a problem anyway. What I do need to limit is the negative x squared plus 4 needs to be greater than 0. Greater than or equal to, it can't be 0, because e to the 0 power would be 1, that'd be fun. I would probably write that as 4 minus x squared. Then you could do a difference of perfect squares. You can do that however you want. 2 and negative 2 are the places on the sign chart. Everyone agree? 2 and negative 2? Something left of negative 2, like negative 3. How would we get a negative? Positive than negative. So between negative 2 and 2, including negative 2 and 2, right? It could be negative 2 and 2, those would be okay. Does everyone agree? That would be the
So with the other one, it like connected with the area with the graph at like in the math. How does this connect to real world?
you'll see tomorrow. We'll do real world problems. Negative 2 to 2 is the domain. This is the picture you would get from that. At 2 and negative 2, you have undefined places. So again, more than anything, we just don't want to make an assumption about what the graph would look like past those asymptotes. I'm comfortable making the assumption from here because I have the slope and I have an initial condition, so I can go, okay, that's what that graph would look like. But outside of that window, I don't know enough. Any questions about that? This is pretty zoomed in. What was it 0 and e squared? 0 and e squared. E squared is a little more than 9. So. Okay. Okay, any questions so far? I think I have an AT question. Lane. Okay. We have time. I want you to try this AP problem, and then we'll be done. This has a little math competition reminder up there. That was actually from my last year's class because it was actually getting close. But since it's up there, I kind of want to point out that you have a better chance than anyone at Greenwood has ever had before because they allow BC students to take the same tests in the math competition as AB students. So last year you were at a disadvantage because you were in True-Calc, because they were in Pre-Cal, which was covering Pre-Cal stuff, and you kind of had to go back and remember Algebra 2 stuff, so that was hard. This year you're at a very large advantage in the math competition, so it's not until the spring, but those of you who are interested, you might want to pull those tests off of UCA's website and kind of get prepped early, and if you want to win something like that. Maybe if you win state, I think you get a little scholarship.
Wait.
We go in regionals, I think you get I don't know what they do with the, I don't know how, but I think every student who won last year in calculus was in BC calculus. Maybe Southside has BC calculus.
You were years ago.
You don't need it for you. What?
Blake was like the math kid from Southside was Blake.
Now, my first year here, I don't remember who, but one of Mr. Bridges' students placed in Regents in AB. Probably. So that's pretty impressive because he was in AB. So I'm not saying it's all AB material. The thing is, you'll be done with AB material next month. So you've got, or they won't be done with AB material until March. So you're just, it'll be kind of old hat, easier stuff to use. Stage check. When you finish this, you can work on your homework. I might go ahead and hand out your stuff to learn before I make you do any of it. But if you want to kind of get your done with your homework and look at your backpack, this is the last AP packet for your district. And if you don't remember correctly, a lot of times those problems on your tests, sometimes they weren't even on the AP packet. So don't forget, understanding AP packets is very important. Okay. I'm going to go ahead and get it out. You can start looking at it if you wish. You don't officially have it decided. So I get 1 over y dy equals secant squared of x dx. Everybody agree? Any questions so far? Natural log the absolute value of y equals is 0 for x and 5 for y. Tangent of 0 is 0. You all go. What is it? E to both sides. Notice that's not an answer choice, right? What do you think they're going to do? Split that up into e to tangent of that, e to the natural log 5, which is going to be 5 e to the tangent of x. And then they don't even make you choose positive. They don't give you the other option today. So it's got to be C. Any questions? Okay, you have your homework. Finish that differential equation worksheet tonight. You can do domain now. Any questions about domain or differential equation? Yes. If you weren't here yesterday, there is a book page at the top. It is the read my directions. Directions in the book are really weird and confusing. Just do the what I call the general solution of the differential equation. Don't see certain or no just the plus C will be in your answer. Just find the general solution. Right. 1 through or 2 through 10 even, you're just doing a general solution to differential equation. Not 2 through right.